In this video, we are introduced to the concept of a limit of a function. Suppose we are asked to sketch the graph of this function that is given here, f of x equal to x cubed minus 1 divided by x minus 1. For all points other than x equal to 1, we can use standard curve sketching techniques. That is, select a value for x and find its corresponding value f of x. But what happens at x equal to 1? We are not quite sure. But if I substitute x equal to 1, we get that f of 1 is equal to 1 cubed minus 1 over 1 minus 1, which gives us 0 divided by 0. This is known as an indeterminate result because we are not allowed to divide by 0 in mathematics. And so we want to get a better idea of what is happening to the function as we get closer to x equal to 1. So I've started this table here where I have some values slightly less than 1 and some x values somewhat greater than 1. And I use my calculator, substitute these values into my function, and note the value. So I've already started here with some values. So when I put x equal to 0.99, I get that f of x is 0.2970. If I say let x equal to 1.01, I get f of x to be 3.03. Let x equal to 0.999, I get 2.997 for f of x. And at x equal to 1.01, I get 3.003. And so, by observing these values, it is reasonable to surmise that as x, we would say as x approaches 1, f of x approaches 3. In limit notation, we use this notation, and so following it, we would write the lim as x approaches 1, f of x is equal to 3. So this is our limit notation. We notice we have this written word, lim, which represents limit. This is the value to which x is approaching, and this is the function under consideration, and this is our limit. So we can now try this example. You can do it using your calculator. Evaluate the limit as x tends to 0 of this function x divided by the root of x plus 1 minus 1. We note that if I substitute x equal to 0, I get 0 divided by the square root of 0 plus 1 minus 1, which again gives me an indeterminate result. And so, as before, we form our table with some values slightly less than 0, some slightly more than 0, and we substitute our values and see what we get. So at x equal to minus 0.01, I get a value of 1.9950. At x equal to 0.01, we get 2.005. at x equal to minus 0.001, or sorry, minus 0.001, yes, I get 1.9995, and at x equal to 0.01, I get 2.0005. And so it appears that our limit is 2, that f of x is tending towards 2. So that even though the function never actually reaches the value of 2, it tends to that value. So we say the limit as x tends to 0 of our given function is equal to 2. So we will conclude by restating what a limit is. A limit of a function f of x is the value the function approaches at a given x value.